All right, so practice of final exam number 1. So they talk about the uniform distribution, right? So we can use StatCrunch. So most of our example require using StatCrunch. So uniform distribution between 50 and 52. So what is the minimum in the case? Because we have to set it up, right? Minimum, maximum. And then it's more than, we don't have to worry about that because they give us more than is greater, right? So greater than 51.1. So we don't have to worry about this inequality. So we're going just to straightforward StatCrunch uniform, right? And then minimum is 50 and maximum is 52. Okay. Let's go to StatCrunch. StatCrunch. Okay. We're going to stack calculator, right? And then there is a uniform. Yeah. Oh, hold on 1 second. I did not sharing here. I have to stop here to share. Okay, so here, let me do this one. Stack calculator uniform, right? Okay, let me click. Then, what was the minimum? So lower limit will be minimum. Does anyone remember? Ah, thank you. Wrong message. 50 and 52. Ooh, good memory. Yes, 52. Okay. And then question was it's more than 51.1. So continuous, equal sign, does not have an equal sign, does not matter, right? Unlike discrete number. So we have only two options, greater or equal to, or less than or equal to. So we are using this inequality 51.1. So what's the probability is the class length is more than 51.1 minutes. So compute. So 0.45, this is the answer. So 0.45, let's go there. Okay, so you might get dizzy, back and forth, back and forth. All right, 0.45. Point 45. Wait. All right. Now, number 2. Take a look. They talk about the bell shape. Has mean 35. Standard deviation 9. And 12. What's the 12 in the case? by each of the 12 receptionists. Receptionist. What's the 12 means? Sounds like a sample size, right? And very good. Thank you, Grandma says. All right, then using empirical rule. So I told you empirical rule in the StatCrunch is not accurate, right? They approximately give us a right answer, but not accurate 100%. So I recommend you to do by hand better. But you can use a StatCrunch in lower curve, 30, 60, 90. You can click that, but that is not accurate. That's why I never explained to you in the class, okay? All right, so by using empirical rule, so I asked you to take a picture, right? So here, what is approximate percentage of daily phone calls numbering between 8 and 26, 26, 62, right? Okay, mean equal to 35. We want to know about the percentage, right? So the in the middle, within first standard deviation is 68, then 98, and 99.7%, right? Okay, let's find out. So right side we have mu plus sigma. So mu sigma, which is 9. Can you please calculate? And other group, ooh, that was really quick. Thank you, direct message. Thank you. All right, so other left side, we have a mu minus sigma, which is 35 minus 9. Thank you. All right, now we have, no space. So we have a mu plus 2 times of 2 times of sigma. So 35 plus 2 times of sigma, which is 9. Can you please calculate? $53. Thank you. Ooh. And then there is mu minus 2 times of sigma. So 35 minus 2 times of sigma. Be careful when you use a calculator. So 2 times 9 first, then subtraction, right? So what do you get? 17. Good job. Ha! We still don't get 8 and 62, but it's almost, right? Let's do one more time. So we have mu plus 3 times of sigma. So 35 plus 3 times of 9. Thank you, everyone, for participation. You're participating. Participation. 62. Okay, last one. We got the 62. How about left side here? So we have, oof, no space. So what about here? Mu minus 3 times of sigma. So 35 minus 3 times of 9. 8. Thank you very much. Okay, we found 8 and 62, which is within 3 standard deviation. So how many percentage is that then? Yeah, how much percentage there? Does anyone remember? That is 99.7%. In the middle, we have, for your reference, so in the middle, we have 68%. Then we have 98% within 2 standard deviation, right? This is a one standard deviation, right? And then within 3 standard deviation, then we have 99.7%. Yeah. Okay, number 3 and number 4, it's about normal distribution, right? So we are using StatCrunch. So I will do at the same time number 3. We have a normal distribution. What's the probability? Z is less than 0.31, right? Then we want to answer for the small places. And this is also between, right? So let me take a picture and then I will show you StatCrunch at the same time. Sorry, back and forth, right? You might get disease. All right, so let me turn off here too. Okay, so we're going to stack calculator normal distribution, right? Stack calculator normal. All right, let me click. Okay. So the first one, number 3, we want to know about the z is less than 0.31. What is the mean and what is the standard deviation? Mean and standard, very good. So mean is 0, standard deviation is 1. Very good. Yeah. Okay, when we use z-score, we are using mean as 0, standard deviation is the 1. Okay, and that is z. Yeah, z is less than 0.31. Click. Okay, that will be, I cannot remember, so let me take a picture. All right. Oh, very good. 0.6217. Good. Thank you for chat. Let me using copy and paste yours. Okay, second one, we have between, right? So between, this between -1 point, so between, click this one between. So that will be z. So -1.72. And then positive, oh, no, negative point, negative 0.52. Okay, click. All right. 0.25881557. So we do round to 4 decimal places, which is 0.2588, right? Okay. 0.258. All right, so let's answer that. All right. Start. Okay, so 0.6217. And this is 0.2588. Okay? All right. Number 5, please read. So this is a mean. This is a mean. 60.5. And standard deviation is 8. And then this is a normal, right? And then we want to find probability at least 82.9. They don't give us any inequality, so we have to figure out, right? So we're using StatCrunch. So everything StatCrunch except 2, right? So StatCrunch, this is for StatCrunch. Let me denote to StatCrunch. How about that? Yeah? StatCrunch. All right. So at least. What is the at least? How do we indicate the at least? X 82.9. How do you do? What kind of inequality we have to use? That or that? Number 1 or number 2? Very good. Thank you. In the chat. Very good. Yes. All right. So we are using that. How about second one? At most. What kind inequality we have to use? At most. Very good. Okay, let's find out. So mean equal to 60.5, standard deviation is 8. We are using in the StatCrunch normal distribution because they said the normal, right? So this is a keyword, what we have to use in StatCrunch, right? Yeah. If they say the normal, then we are using the StatCrunch normal distribution, right? All right. Let's go over. And I have to turn off here. All right, so mean was 60.5. Thank you. Thank you. Let me use it. Copy and paste yours. And then standard deviation. Thank you. Both of you. Copy yours. Okay. Now we have the first one, standard. And x is greater or equal to means at least 82.9. Thank you. All right, so the probability is at least 82.9, which is 0.00255513. How they say about the decimal? They don't say any decimal. So let me just using everything, copy and paste, better, right? Because they don't say anything. The first option is just copy and paste. Then we don't have to think about the round off, right? If this is not working, then we answer for decimal places. There is a second option, all right? If they don't say anything about the round off. So 0.0025553. Okay, now second one, we have x is greater than 36.5. Greater, change the inequality. So we have a point 0.0013499, right? Oh, there we go. Oh, 68, 98, 95, 99 point ticks. Yeah. Why sometimes they give us, probably mean and standard deviation? Anyway. Okay. So those things, we can answer that, right? Where is recording? Okay, I paused the recording. So this is one I was talking about. It's not the why I was talking 30, 60, 90. Okay, so 68, which is a 68% in the middle, 95 next one, and then 99.7 ticks, right? Okay, so this one I was talking about the empirical rule. Yeah, so let me just using the first or second example. Let me do it. Second example has uh mean 35 and then standard deviation is 9. And then we have to, we cannot use this one because we have to make a between, right? So the question said 8 and 62. What's the percentage between 8 and 62? Between 8 and 62. Yeah. So I click that. I click between, then I click the 60 and 68, like the empirical, right? So this one gives us, if we express as a percentage, 99.7%, right? Which is good, which is the same as answer, right? But as I told you, the answer is not gives us 100% all the time correct answer, all right? They give us a little bit off. It's not big difference, just a little bit off the answer. For example, the answer is, in that case, is obviously 68, 95, 99.7%. The question asks us a percent. So there is only 3 answer, right? So definitely this is 99.7. But then if they ask us about what is the X, then they give us a little bit different number. like 8. If 8 was the answer, they give us 8.2, like that. If the answer is 62.5, then they give us the answer 62.2, like that. Okay? But we need an accurate answer. Make sense? Okay. Stop sharing. All right. Let me recording. Sorry. Make this is back and forth, those StatCrunch and note. Yeah. Okay. Where is the recording? Oh. Okay, so this answer is 0.00255513. We can just make a copy and paste, right? This is 0.0013499. All right. Okay. So number 6. Number 6, normally distributed, and the mean is 0, standard deviation is 1, right? And then we want to know about the probability. When the probability is 0.1705, we need to find the C, such as C, right? Okay, look. Using this score, coincidence, right? So mean equal to 0, standard deviation is 1. Can you please find the C? Yeah. How? Just to set it up. What it is, right? So mean equal to 0, standard deviation is the 1. And other side, we make a 0.1705. And then find the C, right? Okay. Let us do this. All right, so standard, right? Mean equal to 0, and standard deviation is the 1, and the z is greater than the number, so we don't know. So that's the question 4, right? And then other side, the probability is 0.1705. That is the z-score. 0.95219. That is actually z-score we are looking for. Yeah, this is too difficult. Thank you in the chat. All right. They don't say anything. Copy and paste. They don't say anything, then copy and paste. Then that such a C will be 0.95219. Yeah. So normally this score 2 decimal or 3 decimal places, right? They don't say anything, just copy and paste. All right, number 7, normal distribution with a mu equal to 125.4, sigma equal to 96.4, sample size equal to 104. Okay, what is the mu sub x bar? What's the formula for that? Mu sub x bar. Mu sub x bar. Thank you. It's mu. Very good. Then we have a 125.4. What's the sigma sub x bar? Thank you so much in the chat. Mu sub x bar. I'm sorry, sigma sub x bar, not the mu sub x bar. Sigma sub x bar. Very good. Sigma over square root of m. Very good, right? Okay. Sigma, which is 96.4 over square root of 104. Can you please calculate? We need to answer two decimal places. $9.45. Can you please confirm? Thank you. All right. Now we have, oh, it's a different one. I thought it's the same. Okay, so number 8, we have mu equal to 136.2, sigma equal to 80.4, and then draw random sample size n equal to 53, and then normal distribution, right? Okay, so find the probability that single randomly selected value is less than 118.5. Okay, so we are using this one StatCrunch. I said SC, huh? StatCrunch with mu and sigma, all right? And this one, look, let's compare. Find the probability that sample of size n equal to 53 is randomly selected with a mean. So this is a keyword, probability with a mean, yeah? Then this is a sampling distribution of a sample mean, yeah? Sampling distribution. Sample mean. Okay, in that case, we are using StatCrunch with mu sub x bar, sigma sub x bar. All right? Okay. Can you please find out what's mu sub x bar? We know that. Sigma sub x bar. Sigma sub x bar, we just did a sigma over square root over n. It's a different number. Can you please find out? So sigma in the case is 80.4 over square root of 53. What do we have? 80.4 divided by square root of 53. Oh, there is the previous one. 11.0438. Confirm? Thank you for your participation. So let me do this one in the StatCrunch. We take a picture. Okay. So the first one, we have, ooh, I need to make a here too. They change the feature in the Zoom. All right. So mu, which is 136.2, right? And then standard deviation is 80.4. And then x is less than, and 11, no, not 11, 118.5. Okay, let's compute. And did they say any decimal places here? 4 decimal places. Okay, then there will be 0.4129, right? Okay, let's do second one. Second one has mean equal to mu, same, which is 136.2. We don't change that. Sigma, which is sigma over square root of n, which is 11.0438, right? And then the question, same, yeah. So be aware of this. So that is sigma sub x bar, which is a sigma over square root of n, right? So that is 80.4 over square root of 53 to get that, right? So let's compute. So 0.0545, 4 decimal places, right? Okay, let's go back. Okay. So that is 0.4129. That is 0.0545. Okay? All right. Number 5. I mean, sorry, number 9. Suppose to proportion, now to proportion, right? Okay. So we have a proportion. And this is 0.46. They talk about the sampling distribution, right? For proportion. And then sample size n equal to 142. What is the mean of distribution? Sampling distribution. So basically they ask us what is mu sub p hat? Yeah. What is the formula for that? Mu sub p hat. with a p hat? P, excellent. Yeah. Okay, so that will be P. Then this is a 0.46. What is the standard deviation? So basically that means sigma sub p hat. Do you remember the formula? It's hard to type, huh? So it's a square root of p, 1 minus p over n. Yeah? Oh. So p, 1 minus p over n. Yes? Okay, so there will be square root of 0.46, 1 minus 0.46. Can you please calculate? Over, and in the case of 142, thank you, in the chat. What do you get this? Let's calculate. Point 0.0418. Thank you. In the chat, both of you. 0.0418. And let's make 5 decimal places. Yeah. Sorry about that. They said at least 5. So 182. Okay. You got it. Yeah. At least 5. Okay. All right. So we have to check that whether it's normal or not. We check the n times p times 1 minus p greater than or equal to, right? So either A or B, right? Okay, let's check that. N times P, 1 minus P. So N equal to 142, P is 0.46. 1 minus P, can you please calculate? 35.2728. So 35.2728, which is greater than or equal to 10. Yes. Yeah. Okay. The last question, probability. So we want to use StatCrunch with mu sub p hat, sigma sub p hat, right? So mu sub p hat, which is p, which is 0.46, sigma sub p hat, which is the formula earlier we have in the first one, 0.04182. Okay, so let's go to StatCrunch. All right, so Oh, hold on 1 second. I have to change here. All right, so mean, which is P, that will be 0.46. And then sigma, so P hat, which is 0.04182. And then the X is less than, so we are using same inequality here now. And then 0.5, 0.5. Okay, so in that case, that would be P hat. Because they say the sample proportion, right? So P hat. Yeah, this is P hat. So we want to know about what's the probability of sample proportion is less than 0.5, right? So compute. They say any decimal? Yeah, they don't say any decimal places, then we just copy and paste. Yeah, so copy and paste. All right. Copy and paste here. Okay. So that will be point 0.83058,515. That's the answer. Okay. Okay, let's move on. Number 10. Okay, please read yourself. And then we want to answer. What kind of answer is this? Okay, if you get confused about the symbol for the random variable means a sample, right? Oh, I'm not sharing. Hold on 1 second. Sorry about that. Thank you. Oh, very confusing. Oh, back and forth, back and forth. Oh, crazy right now. All right. Sorry about that. Okay. Number 10, please read. And then you've seen this one before in your homework. So 11% of all Americans are left-handed. All right. Okay, this one, they talk about random variable, then think about the sample, right? Okay, so they ask about 11%. Then what is this? Is it mu or is it x bar or is it p or p hat or x? What do you think? We have a percentage. What is this then? Thank you, direct message. This is a P hat, right? So percentage means P or P hat, right? Well, I said that random is a sample. So sample proportion, right? So that would be that sample proportion. Okay, let's take a look number 2. The second one. What do you think about this one? Number 1, oh, A, B, C, D, E. What do you think about that? Oh, you need to see this. Yeah, example. A, B, C, D, E. A, excellent, because think about the sample, right? And then we have 11%. We have a percentage of 140 sample of 140 students, right? Selected students from the college that are left-handed. Excellent. Okay. All right. Now, we don't need that statement because we knew that parameter involved with this problem, right? So we knew that p hat, which is a sample proportion, which is a statistic, right? Then what's the parameter involved with p hat? Excellent, it's a p. What is the basic description of a parameter of the in the context? What do you think? Which one is best in the A, B, C, D, E? B, excellent, because we can see the all students, right? Parameter, yeah. So means that parameter population, proportion, so percentage of all students, right? Okay, we need to fill the correct non-alternative hypothesis test. All right, so I want to read again, and then can you please set it up? What is a null hypothesis and alternative hypothesis? Null hypothesis, how do you set it up? Null? Thank you in the chat. So parameter equal to number, right? So in that case, p equal to 0.11. So we do that. What about the alternate? Yeah, p is less than because they said the lower in the case, right? So that means p is less than 0.11. So let's do it. So I don't know how to set it up. So p is equal to 0.11. So I think we choose this, we choose that. So null hypothesis test always equal, right? And then alternative hypothesis p is less than 0.11 because lower it says lower, so I need a pick. P is lower. Okay. Now, oh, type 1 error. So what was the type 1 error? Type 1 error. Does anyone remember type 1 error? Oh, A. Okay, so type 1 error said that reject the null hypothesis test when the null hypothesis is true, right? Okay, so reject. So we have a null hypothesis, which is the proportion equal to 0.11, alternative hypothesis lower than the number, right? Okay, so we do rejecting that all students from the left-handed is 0.11 when the actually really 11%, right? Okay, very good. This is the one, right? Excellent. This is the one. Okay, let's move on. What about type 2 error? What's the type 2 error? Thank you, Drew message. So is it F? Okay, type 2 error said that do not reject the null hypothesis test, right? When the alternative hypothesis is true, right? Okay, so is it fair to reject the same, fair to reject? Fail to reject. Fair to reject the null hypothesis test, but actually the alternative test is true, right? So the the F is the correct answer. Yeah. Okay. Let's do number 11. All right. So 11, we are using also StatCrunch. Okay. So let's see. We have a Z-score. Then we want to find the p-value. We answer for the small places. Okay. So basically just a normal curve is the same. But we have to understand what the p-value means, right? So it's a tail probability. Okay, since this score is negative 1.423, so that means left tail. Okay, let's find out. It's equal to negative 1.42. All right, so z equal to, if we are using z-score, make a 0 and standard deviation equal to 1, and then z equal to negative 1.423. We want to know about the probability. That is the one. And then they ask us for decimal places. So let's say using 0.0774 then. Yeah, that's the answer. Okay, let's go back. Okay. So answer will be 0.0774. All right. Okay, number 12. Uh, number of successes is x equal to 150. Sample size is 242. And then null hypothesis is proportion equal to 0.71. Oh, and then alternative hypothesis test, right? So they don't give us. I give it to you hint. Assume that alternative hypothesis is a two-tailed test, right? Okay, this means H sub A, P is now equal to 0.71, right? Okay, now we want to know about sample proportion and test statistic. So let's do it. StatCrunch again, right? So StatCrunch, we are using everything. So we're going to stack, proportion stacks, one sample with a summary. Yeah. Okay, hold on. Let me do here. You cannot see. Okay. Stack, proportion. Ooh. Proportion stacks. And one sample with a summary. Yeah. Okay, let me click. I cannot erase. Okay, sorry about that. I cannot erase that circle. Okay. Number of successes from the given information, which is 150. And sample size, which is 242. And then hypothesis test, 0.71. And now equal to, right? And then we want to know about the test statistic. So show critical value. And then they don't say anything about the alpha. We just make a 0.05. All right. All right. So let's compute. So look, Z stacks will be test statistic. This is the test statistic. So we will learn t-test statistic later on. I mean, we learned already, right? So let's make a z-test statistic for this one. Yeah. Okay, they said around two decimal places, so there will be negative 3.09. Okay, sample proportion here, right? That is a sample proportion 0.62 then. Yeah. Okay. Actually, we did not have to click that critical value earlier. All right, let's do it. Ooh. Okay, so we have sample proportion p hat, which is point. Oh, it's a 3 decimal places. No, hold on 1 second. Let me just take a look. Let me go to the, it was 0.6198. So I'm gonna answer 0.6. Oh, so 3, give it to the 1, 2, 0. Okay, still 0.62. Yeah, and this one is negative 3.09. Okay, all right. Number 13, please read. So we want to answer hypothesis test. So null hypothesis test. Thank you. Do you make sense? How do you set it up? Null hypothesis test. Is it P? Good. Thank you, Durang says. Is P equal to 0.48? Excellent. And then, so we using that, the alternative hypothesis, they say that in different than, right? Different than, so it's different. So it's not equal to, so P is not equal to 0.48. Thank you in the chat. All right. So we're using P is not, and with a number. Okay, once again, we have to using the test statistic. All right, so in order to do that, we have to have X and N, right? So number of successes and the sample size. Okay, this will be sample size because they say so, right? This is N. And this will be X, number of successes, right? Okay, let's do it. And then level of significance, 10%, which is zero point 0.1. Okay, so same as earlier, let's say using that. Okay. I cannot see. Okay, yeah. Proportion stacks, one sample with a summary. Click that. Number of, oh, you cannot see. Hold on 1 second. Number of successes will be 158. And sample size of 314 and hypothesis test n equal, p equal to 0.48 and it's not equal to, right? Okay, now we have to click this one in order to type significance. So it's a 0.1 and then compute. All right. So the question asks us about test statistic, right? So this is a test statistic, z-test statistic. And then the question asks us about p-value, right? Okay, so let's compare with alpha. So alpha, which is 0.1, how do we conclude with the p-value with alpha, level of significance? How do you do that? Okay, then I'm gonna ask you this way. Is it p-value is less than alpha or greater than alpha? P is greater? It's greater, yes, it's greater. Then we do not reject the null hypothesis test, right? Okay, let's do it. Let's answer. Slow. Come on. Okay. All right. So test statistic, they say that for the small places, so let me using 0.8223, p-value 0.4109, and then based on, so we have a p-value is greater than alpha, which is 0.1, 0.1.10. Can you please choose A, B, C, D? B, thank you. So B, fail to reject, do not reject the null hypothesis test, right? Okay, why we do not reject, fail to reject? Can you please choose A, B, C, D? Fail to reject D? There is not enough evidence to support a claim. Excellent. Very good. Good job. Okay. Now, number 14. D is dog, right? Okay, number 14. Please read. Okay, in order to answer two-tail test, right-tail test, left-tail test, we have to set it up. Null hypothesis test, alternative hypothesis test, right? This is 14. What is that? 14. What's the null hypothesis test? Null hypothesis test? Very good. Thank you. In the chat. So null hypothesis test is average, right? Equal to 40 days. And then they ask us about average larger, right? So larger 40 days. Okay, so we have right tail test for that. Okay, p-value. We know only the t-test statistic. All right, so how do you find the p-value? It's a probability, right? Okay, so let's do it. T-distribution. So we have a survey of 16 college students. That will be N. Okay. So let's do this one. P-value. Let me take a picture. All right. So we're going to StatCrunch. All right. So we're going to T, right? So stat calculator T. Let me hold on a second. So stack calculator T. Yeah. Click that. All right. Let me delete. Degree of freedom n equal to 16. So what's the degree of freedom then? Excellent. And minus 1, which is 15. So we have 15 there. And then right tail, right? So we make a right tail. And then we want to know about the p-value is the probability there. So that will be 1.39. Compute. Yeah. They say that 3 decimal places. So point 0.036. Yeah, that's the p-value. So n minus 1 degree of freedom, which is 16 minus 1, which is 15. Yeah. And then this is a t-value, t-score, right? Make sense? All right. Score. I am too busy. Okay. Where you go? Am I here? Okay. All right. So StatCrunch point 036. So using with DF. All right. Number 15. Oh, here. 15. Please read. Once again, null and hypothesis test. Please set it up. Excellent. Mu equal to 40 and mu is greater than 40. So mu equal to 40. So mu equal to, and then mu is greater than 40. Let's find out. It's greater. Yeah, that's why greater. Yeah, very good. Okay, what kind of type of test? Left tail, right tail, two tail. B, right tail, right? Very good. Significance level. Can you please read what's the significance level there? 0.05. That is a significance level. Excellent. That is alpha, right? Okay. So 0.05. Okay, we need to calculate the test statistic. And then p-value. And then we need to conclude whether reject the null hypothesis or not. And then why? Yeah. Okay, let's do it. So test statistic p-value. Let me take a picture. So before we go in, mean is 40. Yeah, greater than 40 pounds. And then let me see. The current world record stands at 143 pounds. So average weight is between 20 to 40 pounds. To reference number 38 blue catfish caught in those. Okay. Oh, they already give us everything here. Yeah, I was looking for those information. So stupid. Yeah, this information, I was looking for that. All right. Okay, so let's go to StatCrunch. All right, so we go to, let's move on here. Go to stack, T stacks, one sample with a summary, okay? Oh, sorry about that. Here, stack, T stacks, one sample with a summary. Let's click that. Okay, sample mean. Sample mean 40.8. And then sample standard deviation is 4.71. Sample size, which is 38. And then null hypothesis test, which is 40. And greater than, right? And then level of significance, which is 0.05. 0.05. Okay, compute. All right. So this is t-test statistic. And this is a p-value. Okay, let's compare with alpha. Alpha equal to 0.05. Does the p-value is greater than alpha or less than alpha? It's greater than. Good job. Thank you. Okay, that means we do fail to reject the null hypothesis test. Do not reject the null hypothesis test, right? Why? Because there is not strong evidence to support the claim, right? The alternative hypothesis test. Okay. Let's go back to 15. Okay, p-value will be how many decimal? 4 decimal places, which is 0.1509. And then test statistic, actually t-test statistic in the case, and 2 decimal places 1.05 because it has 1.40470. All right. Okay. Do you reject? Can you please choose A, B, C, D? Thank you in the chat. D. So we fail to reject the null hypothesis test since p-value is not less than. Okay. Very good. Thank you. How about Z? Best represent conclusion. Thank you. Also D. It's dog. Okay, there is not sufficient evidence to sample evidence to support, yeah, this one, right? Mean weight of the fish in the John, whatever reservoir, is greater than 40 pounds. Okay, very good. Okay, number 16. Please read. All right, so point estimate. What's the point estimate? Point estimate? Point estimate is 0.16. How did you get that? Point estimate is p hat x over n, right? So sample, which is 1900, and number of success is very good, 304. That's how you got it. Very good, excellent, 304, which is 0.16. Okay, margin of error. Okay, margin of error, I'm gonna tell you indirect. Yeah, indirect. 95% confidence level, right? And then we're gonna create the confidence interval, right? So they don't say, oh, they don't really say. Okay, so let me just show you. Okay, so go to StatCrunch. Is it p-hat related? Then proportion stacks, one sample with a summary, right? Okay, let's go. Number of successes was, and I can see that in the chat, 304. And then sample size, which is 1900. Okay, now confidence interval with a level of significance, which is 95%. So compute, right? Okay, so we have an upper limit, lower limit. There will be lower bound, upper bound, right? Oh my gosh, I did not share. Do again, huh? Sorry about that. Let me do again. Stack, proportion stacks, one sample with a summary. Number of successes 304 and 1900. And level of confidence 95% compute. Okay, now So this is a lower bound, this is a upper bound, right? Okay, we can use that like a confidence interval notation with a comma, right? Okay, so we knew that this one is p hat plus margin of error. If we want to know about the margin of error, subtract the p hat, right? So p hat was your classmate gave us 0.16, yeah? So we have minus 0.16. Can you please calculate? There will be margin of error. 0.1764a minus 0.16. Oh, you said without decimal. I mean the um, percent form. Good job. 1.6, yeah. So there will be, you have then 1.6, so 12.016 then 12, yeah. And then they say that that's a percent notation. So we make 100%, then there will be 1, 2, so 1.6%. But they say that don't put the percent notation, right? And then one decimal places. Yeah. Okay, that is the one. All right. Number 16. Okay, so the margin of error will be 1.6% form, but they don't allow to use percent notation, huh? Right? Okay, so express your answer percent form around one decimal place. Do not type, right? Do not type percent notation. Okay, now, can you please answer A, B, C, D? So let me write down lower bound, upper bound. So we have lower bound 0.143 and upper bound we have a 0.176. So if we make a 1, 2, and then there will be 4 then, 1, 2, then 14.4% and 17.6%. So between that, what do you think about that A, B, C, D? A, we are 95% confident that the proportion of Americans who have never left their home state is between 14.4% and 17.6%. Okay, that is a good one. Let's say, okay, you guys okay with this? All right, next one. Another sociologist believes that the proportion of Americans who have never left their home state is 17.6%. What do you think? What do you think of this claim? So A, B, C, D, what do you think? B, okay, thank you. Thank you in the chat. So this is B. Excellent. The claim is inside the interval, so it's reasonable. Very good. Okay. All right, number 17. Okay, so find this is about the margin of error. I showed you earlier, right? So let me show you only one. We have to have so indirect StatCrunch, right? StatCrunch indirect way. Okay, so we have this is and this is x and this is p hat, right? All right, then in the case 90%. So let's do it. And then round to 2 decimal places. Percentage round to 2 decimal places. Okay. So this is what we did earlier. Same. Find the confidence interval and then subtract the p hat, right? So we are using proportion. One sample with a summary. Click that. Number of successes will be 1176. And then sample size will be 2333. And then confidence interval. It's 90% for the first one. And then you try the second and third one, right? And then we do compute. That's it. Okay. Upper limit. Oh, I did not share. Sorry about that. I'm rushing this way. Okay, so once again, go to how we get this one stack, proportion stacks, one sample with a summary, right? Then we fit out what is X, what is N, what is the level of confidence, then click, right? And we have this one, all right? Then minus, we do minus P hat. So okay, let's change the percentage because the p hat is given percentage, right? So 1, 2, so 52.109 minus 50.407%. Can you please calculate? There will be margin of error. So this is the p hat plus e minus p hat, right? There will be e. So 1.702%. Thank you in the chat. So we have to answer 2 decimals, so 1.70%. Okay. All right. 1.70. There we go. All right. Let's answer all the questions. Okay, so we have 90%, so it's a 1.7%. Yeah, two decimal, so 1.70. Sorry about that. You guys will give it to me 702, right? So 1.70, same as 1.7, right? So please try two problems in the down there, 95%, 99%, right? Okay, let's answer this one. Can you please answer? Can you please answer this? A, increase, decrease? Excellent. Thank you to the message. Okay, we do increase, decrease. All right, so margin of error reflect precision or or accuracy of our estimate, right? So if confidence level increases, we knew that level of confidence wider, then the number is getting bigger, right? Means the margin of error increases, right? So margin of error is big, that means the precision is decreases, yeah? Smaller margin of error is more precision, all right? More accurate. Okay, now, number 18. So we are using sample size, level of confidence, and then find the t-value, find the t-value. Okay. So that will be probability, right? So other side, let me show you. StatCrunch. With the degree of freedom, right? All right. StatCrunch. Where's my cursor? Okay, so we're going to, let's see, come on, stack and calculator T distribution, right? Oh, I'm not, okay. I'm not showing. Oof. Okay, so we have stack calculator T, come on, T, yeah, click that. All right. So the sample size is 15. What is the degree of freedom? 14. Thank you very much. 14. And then 99% level of confidence. That means other side 0.99. Okay. Then we knew that there is a between, right? And then we are using the bigger number, right? Oh, 0.99 again. And then we are using the positive number, right? So there will be sorry, 2.97. How many decimal they want? They don't say anything. If they don't say anything, just copy and paste. But normally G score, T score, T value, 2 or 3 decimal. But then we don't want to deal with round off. So using only the positive because the T value, T sub, G sub always talk about the tail, right? And right tail, basically, right? So that's why we are using positive part. And then if we choose there, that means like that, yeah? Okay, so 2.9768. 2 point. So this is a 2.9768. So I keep just the decimal places because they don't say anything. Number 19. So 21 is the last one. So number 19, we want to create, right? The confidence interval. And then margin of error, right? StatCrunch. So let me take a picture. All right, so X bar, not the P head, right? So if they give us X bar, that's the keyword we're using the T stacks instead of a proportion stack, right? So we have to recognize and the margin of error there. So let's do it. T stacks. So go to, come on, T stacks here, one sample with a summary. Okay, sample mean given, which is 47, and standard deviation given 2, and then sample size 23, and then confidence interval, level of confidence is 90%. Compute? Okay, so that will be lower bound, upper bound, and then what they, margin of error, so 2 decimal places, yeah. So oh, I'm not sharing again. Oh. All right. Okay, I'm gonna do one more time. Go to stack, T stacks, one sample with a summary. Yeah, click that. And then fill out the mean, standard deviation, sample size, what they give us, right? And then confidence interval. I believe 95% there. Sorry, 90%, right? So that's how we got it here, okay? Now, margin of error, we subtract, right? So subtract p hat. So what was the p hat? Sorry. In that case, is sorry about that. Yeah, the uh, X bar, right? So this is actually X bar my plus margin of error. So we take out the X bar, and then the direct message said that 0.72. Excellent. So X bar is 47, then we get 0.72. That is the margin of error. Yeah. Okay. 0.72. Two decimal places. All right. Let's just stay here a little bit. We're almost done. Okay. Thank you. 0.72. 0.72. 0.72. Export. Let's see. Okay. Number 20. Confidence interval, right? Okay. We are using every information here. Confidence interval. And number 21 is about the sample size, I think. Okay, so let's finish it 21, then 20, then 21, then we are done, right? Okay, 20, confidence interval again. So it's a mu. They give us, that means X bar, right? Related with, that means T stacks. Let me make here first. Okay, T stacks, one sample with a summary. And sample mean, I am using 35.7 there. And then standard deviation is 20.1. Oh, 35.7, so 20.1. And then sample size is 525. And then confidence interval with 98% of level of confidence. Okay, so there will be that. Lower bound, upper bound, right? Okay. Uh, one decimal, please. Okay. One decimal. One decimal. Okay. Last problem, maybe. Soon. Um, so lower bound will be one decimal. So 33.7 because 33.65. I'm not sharing. Okay. Hold on. Sure. So lower bound has a 33.65, one decimal, so 33.7, and upper bound 37.74, so 37.7. 37.7. Okay. Ah, all right. So this is the answer. All right. Last problem. Last problem. Sample size. Yeah, we're looking for. Let's find out, is it related with a proportion or is it related with a sample? I mean the uh, mean, right? What they say, is it proportion or mean? Proportion or mean? Answer quickly. Mean. It's mean, right? It's mean. Okay. Then we are using G stacks for StatCrunch. Okay, let's do it. Uh, we have within 3 years, there will be margin of error, right? And then we want to have a double size, right? So this is a margin of error. Then double size, 3 times 2, which is 6, yeah? Okay, now standard deviation, we have 17 years and 97% confidence level, right? So this is the last one. Let's do it. Okay, so we're going to this text, go to with a one sample with a summary. Oh, no, 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 sorry about that. I have just a habit. Stack, this text, go to one sample, and then we go to with sample. Yeah, I'm not sharing again, huh? Hold on 1 second. All right, I am sharing right now. Oh, oof. Okay, so stack, this text, one sample with sample size. Click that. All right, now confidence level will be 97%. And then width, which is a 6, double over margin of error, right? And then standard deviation, which is 17 years. And then sample size, we are looking for 152. We don't worry about the round up, right? Because StatCrunch does it for us, 152. Okay, 152. All right, let's do it. We finish. 152. Okay. All right, sample size is 152 by StatCrunch. All right. And just so we do remember double of in GSTEX. Okay. All right. Let me finish this one. Thank you for attending the review section.